Hello everyone, I welcome you all for this session, that is unit number 6 LPC 21448 peripherals. In that session 5 PLL resistors. In the last session we have covered PLL features and we have discussed about the block diagram of PLL and we have listed the different resistors available in phase locked loop, that is PLL. In this session we are going to learn the bit structures of different resistors available in phase locked loop. There are four resistors: PLL control resistor, that is we call it as in the PLL con in short. Then PLL configuration resistor, that is PLL CFG. Then PLL status resistor, PLL stat resistor. Then PLL feed resistor, that is PLL FEED. Okay, and we're going to cover some of the assessment questions on this resistor set of PLL. Look into this slide. This is the bit format or the resistor format of PLL con resistor. The PLL con is an 8-bit resistor, and here you can see two sets of PLL 0 con and PLL 1 con resistors. So this PLL 0 con is related to PLL 0, that is control resistor for PLL 0. Then this PLL 1 con is PLL control resistor for PLL 1. So here this PLL con resistor for PLL 0 and PLL 1 contains only two valid bits, that is PLL C and PLL E. So PLL C is nothing but PLL connect bit. Okay. Then PLL E means PLL enable. This is connect. So in order to use the PLL frequency or the PLL output signal, as I said, PLL 0 is used to generate the system clock, that is CCLK, and PLL 1 is used to generate the USB clock at the rate of 48 megahertz. This PLL enable should be 1. After a valid PLL feed, this bit will activate the PLL. So in order to use the PLL frequency, the PLL E should be 1. And for if you write 1 here, there must be a valid PLL feed sequence. As I said already, the valid PLL feed sequence is AA and 55. So then only this bit will be valid or activated. So PLL connect bit, so when PLL enable is 1 and C becomes 1, so after a valid PLL feed sequence, then only the PLL gives the clock signal to the microcontroller or the processor, and here all other bits are reserved. Okay, so this PLL CFG resistor, CFG in the sense it is configuration resistor, and you have again two sets, one for PLL 0 and one for PLL 1. So in this resistor, it's an 8-bit resistor. Out of 8 bits, these 7 bits are used and 1 bit, that is bit number 7, is reserved. So from bit 0 to bit 4, it is used for M cell bits. So in order to select the value of M, so there are 5 bits in the sense you have the alternatives from 1 to 32. As we have seen already, the multiplier value M is depending upon these bits. If all zeros, it is 1. So if all ones, it is 32. So like that. So here the multiplier value is decided by these bits. Then P select bits, that is P cell bits. There are 2 P cell bits. Okay. So based upon the 4 combinations, the P cell values, that is P value will be 2, 4, then 8 and 16. So this is the P value. Okay. So totally, so this PLL configuration resistor is used to set the multiplier and the divider values. And one more thing, the changes to the CFG resistor, if you write anything, that is multiplier and divider values, it will not take effect until a valid feed sequence given to this PLL feed resistor. This is very important. Okay. So until and unless the valid sequence in this Pll feed resistor, that is AA55, so whatever may be the data you have stored in this Pll configuration resistor will not be effective. Okay, so this is about the Pll configuration resistor. Okay, so here you can see here M cell bits. Okay, M cell bits. So PLL multiplier value, it can be from 1 to 32, then P cell bits 1 to 48. Okay, so now this PLL stat resistor, as I already told you, PLL stat resistor is used to read the PLL parameters. So these are the parameters. So here you can see M means multiplier value. So M cell bits, then P cell bits, then PLL connect bit, then PLL enable bit, and one extra bit is here, that is P lock. It's a read only resistor. It means this status resistor will give you only the status of the configuration and the control resistor bits. So these two bits PLLC and PLLE are the bits of PLL configuration resistor. Then these P and M bits, P and M bits are the bits of PLL configuration resistor. So, and this is one extra bit is here, that is lock. So bit number 8. So this is bit number 8, this is reserved. Then 9, you can see here bit number 9, it is a PLLC, that is read back PLL connect bit. And when these two are 1, then it will give the source to microwave, as we have studied already. The only extra bit is here is, so that is P lock. So it reflects the PLL lock status. So it means you have designed the PLL for a particular clock frequency or the USB clock. Then if 0 is written into this bit, okay, so the PLL is not locked. In the sense, if 0 is written, the clock frequency may get varied. If 1 is written, so whatever the designed clock frequency at this point will be supplied to the chip peripherals. Okay, so this is all about PLL stat resistor. Then PLL feed resistor. So in this resistor, as I said, if you write AA, okay, so AA and 55 looks like a clock, alternate 1 and zeros. So when you write this sequence AA and 55, then only the PLL con and the PLL configuration resistor changes will be the values which we have stored in configuration resistor and the control resistor will be effective only when this AA and 55 is loaded into the PLL feed resistor. Okay, move on to some of the assessment questions based on these 4 resistors: PLL con resistor, PLL configuration resistor, and PLL stat resistor, then PLL feed resistor. So you just remember PLL configuration control resistor, that is PLL con resistor, contains only 2 bits, that is PLL connect and PLL enable. Then in PLL configuration resistors you have multiplier and divider values, 5 bits for multiplier, then 2 bits for a divider. Then multiplier values ranges from 1 to 32, but maximum M should be only 6 because of the CCLK output limit, that is 60 megahertz only. Then the divider values are 2, 4, 8, 16, because P value will be 1, 2, 4, 8, but it will be multiplied by 2 in the block diagram, you can see that. And in PLL stat resistor, it is a read back resistor, it is a read only resistor. You need to get the status of M and P values, that multiplier and divider values, and also the connect and enable bits, and also the lock status, whether it is locked to a particular frequency or it's maybe variable. Okay, so these are all the things we have studied. Now let us look into some of the questions. In PLL module LPC 2148, PLL con resistor is used to, as I said already, it is used to enable and connect PLL. In the second question, in PLL module, PLL configuration resistor is used to configuration. So as the word comes configuration, you need to remember multiplier and divider value. to set the divider and multiplier value. Okay, so then this PLL module, the Pll Stat Resistor, that's the PLL parameters. What are those PLL parameters? Multiplier and divider values, PLLC and PLLE enable and connect bit, and the P lock bits. So these are all called PLL parameters. The feed sequence must be which one? In Pll Feed Resistor, that is AA and 55. Now, which resistor of PLL contains multiplier value? So you can answer very easily, that is PLL CFG resistor, configuration resistor. So thank you one and all. I'll be very thankful to our moderator and expert, and thank you one and all.